Module 2, Data Collection Methods. Submodule 2.1, Primary Data Collection. Surveys, interviews, and focus groups. Primary data collection involves gathering new data directly from original sources to address specific research questions. This method is particularly valuable for startups as it provides first-hand insights into customer preferences, behaviors, and market trends. The primary data collection techniques include surveys, interviews, and focus groups. Surveys. Surveys are a widely used method for collecting quantitative data. They involve asking a large number of respondents a set of standardized questions. Surveys can be administered through various channels such as online platforms, telephone, mail, or in person. Designing effective surveys. Define objectives. Clearly define the objectives of the survey. What specific information are you seeking to gather? This will guide the development of the questions. Question types. Use a mix of closed-ended questions, multiple choice, rating scales, and open-ended questions to capture both quantitative and qualitative data. Question clarity. Ensure that questions are clear, concise, and free of jargon. Ambiguous questions can lead to inaccurate responses. Logical flow. Organize questions in a logical flow, starting with general questions and moving to more specific ones. This helps in maintaining respondent interest and accuracy. Pilot testing. Conduct a pilot test of the survey with a small group to identify any issues with the questions or format. Use the feedback to refine the survey. Incentives. Consider offering incentives to respondents to increase participation rates, especially if the survey is lengthy. Interviews. Interviews involve direct, face-to-face, or virtual conversations between the researcher and the respondent. This method is ideal for collecting in-depth qualitative data and gaining a deeper understanding of complex issues. Designing effective interview guides. Research objectives. Define the key objectives and topics that the interview will cover. This ensures that all necessary areas are addressed during the conversation. Open-ended questions. Use open-ended questions to encourage detailed responses and explore respondents' thoughts and feelings in depth. Probing questions. Develop probing questions to follow up on initial responses. This helps in uncovering deeper insights and clarifying ambiguous answers. Flexibility. While having a structured guide is important, be flexible to allow the conversation to flow naturally based on the respondent's answers. Recording. With the respondent's consent, record the interview to ensure that all details are captured accurately for later analysis. Focus groups. Focus groups involve a small group of participants discussing a specific topic, guided by a moderator. This method is useful for exploring group dynamics, perceptions, and ideas. Conducting effective focus groups. Participant selection. Select participants who are representative of the target population and have relevant experiences or opinions on the topic. Discussion guide. Prepare a discussion guide with key topics and questions to steer the conversation while allowing for flexibility. Moderation. The moderator should facilitate the discussion, encourage participation from all members, and manage any dominant voices to ensure balanced input. Environment. Create a comfortable environment where participants feel free to express their opinions without judgment. Recording and note-taking. Record the session and take detailed notes to capture nonverbal cues and group interactions that may not be evident in the recording. Submodule 2.2, Secondary Data Collection. Utilizing existing data sources. Secondary data collection involves using data that has already been collected by other sources. This can include data from government reports, industry studies, academic research, and commercial data providers. Advantages of secondary data. Cost-effective. It is often less expensive than primary data collection as the data is already available. Time-saving. Accessing existing data can save significant time compared to gathering new data. Large samples. Secondary data sources often involve large, representative samples, providing comprehensive insights. Assessing the reliability and validity of secondary data. Source credibility. Evaluate the credibility of the data source. Reliable sources include government agencies, reputable research organizations, and established industry bodies. Data relevance. Ensure the data is relevant to your research objectives. It should be recent and specific to the context you are studying. Data accuracy. Verify the accuracy of the data. Check for any signs of bias, errors, or inconsistencies in the data collection and reporting process. Methodology transparency. Assess whether the methodology used to collect the data is clearly documented and appropriate for your research needs. Comparative analysis. Compare the data with other sources to validate its consistency and reliability. Submodule 2.3, Sampling Techniques. Understanding sampling methods. Sampling involves selecting a subset of the population to represent the entire population. The choice of sampling method affects the accuracy and generalizability of the research findings. Probability sampling. Probability sampling methods ensure that every member of the population has a known, non-zero chance of being selected. This increases the likelihood of obtaining a representative sample. Simple random sampling. Every member of the population has an equal chance of being selected. This method is straightforward but requires a complete list of the population. Stratified sampling. The population is divided into subgroups, strata, based on a specific characteristic, and random samples are taken from each stratum. This ensures representation from all key subgroups. Systematic sampling selects every nth member from a list of the population. This method is easier to implement than simple random sampling and can be equally effective if the list is randomly ordered. Cluster sampling. The population is divided into clusters, and a random sample of clusters is selected. All members of the selected clusters are then surveyed. This method is useful for geographically dispersed populations. Non-probability sampling. Non-probability sampling methods do not provide every member of the population with a known chance of being selected. These methods are often used for exploratory research and when probability sampling is impractical. Convenience sampling involves selecting participants who are easily accessible. While this method is convenient, it may not provide a representative sample. Judgmental sampling. The researcher uses their judgment to select participants who are believed to be representative of the population. This method relies heavily on the researcher's expertise. Quota sampling, similar to stratified sampling, but participants are selected non-randomly within each stratum. This method ensures representation from key subgroups but may introduce bias. Snowball sampling. Existing participants recruit new participants from among their acquaintances. This method is useful for reaching hard-to-access populations but can lead to sampling bias. Determining sample size and ensuring representativeness. Sample size determination. The required sample size depends on the research objectives, the desired level of precision, the population size, and the expected variability in the data. Statistical formulas and software can help calculate the appropriate sample size. Ensuring representativeness. Use probability sampling methods wherever possible to enhance representativeness. For non-probability sampling, ensure a diverse range of participants to mitigate bias. Randomization. Randomization techniques, such as using random number generators, can help ensure that the sample is representative of the population. Adjusting for non-response. Account for potential non-response by increasing the initial sample size or using follow-up techniques to encourage participation. Submodule 2.4, Data Collection Tools. Using technology and software for data collection. The use of technology in data collection can enhance efficiency, accuracy, and ease of data management. Several tools and software are available for various types of data collection. Online survey platforms. Qualtrics, a sophisticated survey platform offering advanced features such as branching logic, data analysis, and integration with other software. SurveyMonkey, a popular tool for creating and distributing surveys, with a range of question types and analytics features. Google Forms, a free and user-friendly option for creating surveys and collecting responses, with easy integration with Google Sheets for data analysis. Interview and focus group tools. Zoom, widely used for conducting virtual interviews and focus groups, offering features like recording, transcription, and breakout rooms. Otter.ai provides automatic transcription services, making it easier to analyze interview and focus group data. NVivo, a qualitative data analysis software that supports coding and analysis of interview and focus group transcripts. Mobile data collection apps. Kobo Toolbox, a mobile data collection app designed for field research, particularly in challenging environments. It supports offline data collection and complex surveys. SurveyCTO, a robust mobile data collection platform with features for offline data collection, real-time monitoring, and data encryption. Ensuring data accuracy and consistency. Training and standardization, train data collectors thoroughly and use standardized procedures to ensure consistency in data collection. Pre-testing, conduct pre-tests of data collection instruments to identify and rectify any issues before full deployment. Data validation, implement real-time data validation checks within the software to catch and correct errors during data entry. Regular monitoring, monitor data collection processes regularly to ensure adherence to protocols and address any emerging issues promptly. Submodule 2.5, Data Management. Organizing and storing data securely. Effective data management involves organizing, storing, and protecting data to ensure its integrity and accessibility throughout the research process. Data organization, use a systematic approach to organize data. This includes naming conventions, file structures, and metadata to make data easily retrievable. Data storage, store data in secure, reliable storage solutions. Options include cloud storage, example Google Drive, Dropbox, and local storage with regular backups. Data security, implement security measures to protect data from unauthorized access, breaches, and loss. This includes encryption, access controls, and secure passwords. Preparing data for analysis. Data cleaning, identify and correct errors or inconsistencies in the data. This includes handling missing values, removing duplicates, and verifying data accuracy. Data coding, for qualitative data, develop a coding scheme to categorize and analyze responses. Use software like NVivo or Atlas.ti for efficient coding and analysis. Data transformation, transform raw data into a format suitable for analysis. This may involve normalizing data, creating composite variables, or converting categorical data into numerical formats. Data documentation, document all data preparation steps, including any transformations or coding schemes used. This ensures transparency and reproducibility of the research. By mastering these data collection methods, startups can gather high-quality data that provides valuable insights for decision-making, driving growth, and innovation. The use of primary and secondary data collection techniques, combined with robust sampling methods and data management practices, ensures that the data collected is reliable, valid, and actionable.